All right, we have begun. This is the assignment false statements about star evolution. You have to go through and tell me the part that's wrong, and then you have to go through and explain, after we've changed the part that's wrong, the correct statement. So let's do this one as an example. All stars go through it. In yours, it says not all stars go through fusion. And we need to say that is false, erase that, and turn it into the part that is wrong is not all, and change it to this. Our first statement, when it's written correctly, would say all stars go through fusion. Then we remember drawing that, insert drawing. Hey, Mr. Wadsworth, I thought we'd already done this unit. Well, yeah, we're still going back over it because it's important. Goes through fusion. We push this hydrogen together and this hydrogen together, and it creates a helium atom and electromagnetic radiation. And I changed the color so that we know that it's a new atom. Okay. Number 2, our star is a high mass star. Is our star a high mass star? No. Our star is a low mass star. So the part that we got wrong would be the high. And we would say our star or sun is a low mass star. Awesome. We can go to number 3. Our sun or our star will turn into a black hole. We could take this two ways. Number 1, our star will not turn into a black hole. The other one is we could say what it will turn into. It will turn into a white dwarf. White dwarf. So we could do either way. I'm just going to go with our star or sun will not turn into a black hole. The opposite is also true. We could say what it will turn into. Our sun will turn into a white dwarf. And then eventually a black dwarf. Okay. Number 4, low mass stars turn into red supergiants. Well, let's say what low mass stars actually turn into. We could take out the super part. So the super part is incorrect. Low mass stars turn into red giants. Red giants are what low mass stars turn into. Okay, number 5. A neutron star has a low density. The low part is the wrong. Low. Neutron stars have very high densities. The way I want you to understand this, if we take the mass of our sun and we squeeze it down, we're going to get such a very large density. So I'm going to scroll down here and I want to teach that to you. Density equals mass divided by volume. So this is similar to fractions. So density equals, that's like saying 1 over 1. If we say density equals 1 divided by a really big number, let's say 1,000, if we go through and we lower the volume, or we take a huge star and we take all the mass from that star, so we'll go back to drawing. If we take the mass of a giant star like our sun, or a star like our sun, and we shrink it down, all we're dealing with is all of this mass contained in such a small area. This is going to be an enormous density. This is the fate of our sun. So thanks for letting me geek out a little bit there. All right. Red giants are what low mass stars turn into. Well, let's go through. Red giants are what low mass stars turn into. So, we've already done that part. Excuse me. We're on to number 6. A supernova is where a star is born. No, stars are born in nebulas. They call nebulas planetary nebulas or stellar nurseries, like at a hospital where all the babies are taken when they're born. We could also say the opposite of a supernova is the end of a star. So, two things. So, stars are born in stellar nebulas, and stars die in supernovas. Oh, I've gone through and I've answered this next part. A stellar nursery is where a star dies. No, a stellar nursery, we'll change it from dies is wrong. And we will change that to a stellar nursery is where a star is born. A stellar nursery is where a star is born. You guys are doing so well. Keep it up. The next stage in our star's evolution is not a protostar. A protostar is a star that is yet to go through fusion. Well, our star's gone through fusion, so it won't turn into a protostar. The next stage, if you can remember, is a red giant. So the next stage of our evolution is a red giant. The next stage of our star is a red giant. Okay, number 9. The number one thing that determines the course of a star's life is its brightness. Brightness. Well, it's not the brightness. The number one thing that determines a star's life pattern is going to be its size. So change out brightness and turn it into mass. Okay, so the number one thing that determines the course of a star's life is its mass. Number 10. When our sun becomes a red giant, it will extend out to Saturn. It will extend out and overcome planets, but it's not going to overcome Saturn. Saturn will be safe. When our sun becomes a red giant, it will extend out to Mars. And I love looking at that idea. The sun as a red giant extending to Mars. I'm trying to find this image. There it is. Let's go with that. Copy image. And here you go. I want you guys, you don't have to include this, but I want you to see that's where it is today. Eventually it'll get out to Earth. And eventually, if we keep going, the sun will extend all the way out to Mars. And then the first planet in the solar system, if Mars gets cooked, would be Jupiter. So thank you for paying attention. Hopefully this helps. Have a great day.